Hello friends, today's topic is surface tension. The objectives of studying this topic is we'll understand the concepts of surface tension, that is definition, what does surface tension mean, and where are the real life circumstances we use this concept. And we'll also study about the derivation, that is Young's Laplace equation, and we'll also look into the problems of previous year gate questions, ESC questions, and also university level questions. Okay, now let us talk about what surface tension is. So let me consider this diagram. Okay, now whatever we are seeing here is this is surface, and here what we are looking in when we zoom in, that is microscopic approach, where we see two water molecules. That is, let us name this water molecule as A and let us name this water molecule as B. Now we all know the cohesive force. We all know two types of forces, that is cohesion and adhesion. In fluid mechanics we study two types of forces, that is cohesion and adhesion. And adhesive forces. Cohesion is the intermolecular force of attraction between. It is a force of attraction between the same molecules. That is, if here it is water, then here if it is water, then here also it should be water. That is, the attraction between these two molecules is cohesion. And if it is mercury, if it is here one more molecule of mercury, here molecule of mercury, if there is an attractive force, there will always be an attractive force between these two molecules. That force is known as cohesive force. And whereas if one is water, one is mercury, that is Hg, the force of attraction between these two molecules is known as adhesion. So when we look into this molecule, there are water molecules surrounding this molecule. Therefore, it has balanced cohesive forces. That is, there are water molecules on top of this molecule and also bottom and surrounding. Whereas if we look into this molecule, there are only water molecules below and beside it, not above it. So there is an unbalanced force over here. So this unbalanced force, what it does is, it acts like a stretched membrane type. So this unbalanced cohesive force, this unbalanced cohesive force gives rise to surface tension. So we have come to know that why the surface tension arises. Now let us look into the formula of surface tension. Surface tension is denoted by sigma. So surface tension is defined as the surface tension force, that is surface tension force upon per unit length. That is, for how much length this surface tension is acting, that is this L, and this is surface tension force. And the unit of the surface tension is, as we know, the unit of force is Newton, and as we know the unit of length is meter, it is Newton meter. This can also be expressed in various other units, like if we multiply meter above and below, it becomes, what is Newton meter is we know as joule, so joule meter square. So we need to remember such important units for GATE exam and ESC exams. So these units are very important. Next, one more thing we need to remember from this chapter is surface tension force of water to air surface is, the value is 0.0731 Newton per meter. Let us also see the reason. Let us also see the reason of why liquid droplet is always in sphere and not like rectangular or triangle in shape. Why this is so? As we have studied from our childhood that sphere has minimum surface area, and if we look into our planets also, our asteroids, most of them are spherical in shape. Why? Because a sphere has minimum surface area, and every object in this universe tries to attain minimum energy, minimum surface energy. And hence this, why this is so, because this increases the stability, this increases stability. And let me give few more examples where if we take look into this. Now let us go back to the formula. What we gave is sigma is equal to Fs upon L. Suppose for sigma for water to air is 0.0731 Newton per meter. That is for every 1 meter. This is the surface tension force. This is the surface tension. Therefore, what is this 0.0731 is Newton. If we take weight is equal to weight is m into g. So 0.0731 is the weight, and this we need to find the m, and if we know g as 9.81. So if we look at what does this m is 7.45 grams. This is what if it will come if we convert it into grams. Otherwise it is 7.45 into 10 raised to minus 3 kg. That is this much of weight can be whenever there is suppose there is a water in the lake, and there is air over here. Whenever there are two interface like this, so that is 7.45 grams. If you keep it on that water surface, it won't drown. Can be supported by this water and air interface. And in real life, where all surface tension is used is it is used in detergents. For example, in detergents concept, that is if we look into microscopic approach of if we take the microscopic approach of cloth, here suppose if we consider here as that this is dust. So there is a surface tension between here if you pour water, the dust or the वो दाग जो भी रहता है वो हट नहीं जाता है. So there is a interface between water and dust over here. So when we add detergents, what it does is it decreases the surface tension, and hence detergents what they do is decrease surface tension, and hence we can easily remove that whatever वो जो भी दाग रहता है वो हम आसानी से काट सकते हैं उसको. चलिए फिर नेक्स्ट इस पे वीडियो पे हम लोग विल go in depth about the derivation, that is Young's Laplace equation, that is delta p is equal to sigma in the bracket 1 upon r1 plus 1 upon r2. In the next video we'll look into this derivation, and after that we'll also later look into the problems regarding GATE, ESA and university. Thank you.